So in this video, we're going to talk about something called vertical angles. And the clue is really in the word vertical, right? So vertical basically means straight up and down, like the eyes of a cat are vertical eye slits, if you've ever noticed those. So in the same way, what does that mean? Well, if I were to label these, actually, let's just do this. Let's call this vertex, okay, A, and let's just go around in a circle. So we'll go A, B, C, D, and E. You can describe these crisscrossed lines as really as a series of rays, right? So you can say ray, remember ray has a vertex, AC, ray AB, ray AE, ray AD. And remember how you do rays. So I would say AC, I would do this, because the vertex is with the A, the arrow goes with the C. And the same thing with all of these. A would be first, right? AB would be like this, with an arrow, AE. Remember that, and then AD. You can describe vertical angles as angles where, those would be vertical, the angles where their sides are opposite rays of the other angle. Okay, so for example, this particular angle here, let's call it angle BAC, right? Because that's the angle. So you'd say angle BAC is a vertical angle. Slightly off there. There we go. Is a vertical angle to angle EAD. And again, the reason why is because the ray AE is opposite of AC. One side of this angle has the opposite ray of the side of this angle. And the same thing with over here. The ray AB is the opposite ray, remember exactly opposite, 180 degrees, of AD. So vertical angles, right, have two pairs of opposite rays. And that's really what defines them. Now, so what are the characteristics? Let me just put that down. So vertical angles have two pairs of opposite rays. That's like a precise, actually, definition. The other thing about vertical angles is that if they do have two pairs of opposite rays, the angles are equal. So I'm going to say angle BAC, this angle, is equal to, or is congruent to as well, but is also equal to angle A or EAD. Okay, so those are the two characteristics of vertical angles. Now, here's a question for you. Is this angle a vertical angle to this one? And the answer is yes. Because, again, ray AB has this one as opposite. This ray has this one as an opposite. So yeah, these are both exactly vertical angles, even though they're not like one on top of another, like a vertical slit, right? So they don't have to be straight up and down. They can be sideways as well. Think of it as opposite angles. That's another way people think of them, all right? So opposite. And that's angles. You got to be careful with that one, though. Because, again, they have to have the two pairs still have to be opposite rays, all right? Now, the characteristic of vertical angles, here's the last thing I want to tell you, is that they're equal. I think I already mentioned that. And I want to give you an example of a problem, okay? So let's say I know that angle BAC, here's an example problem, angle BAC is equal to 98 degrees. Okay? And what I know about angle EAD is that it's x plus 40. Create an equation that would actually solve for the x. So you have to use a little bit of inductive reasoning, right? I know that BAC is equal to EAD. Therefore, 98 is equal to x plus 40. So 98, let's use our Roman numerals again. 98 is equal to x plus 40. And now you just solve for the x. Subtract 40 from both sides. You get 58 is equal to x. Okay? A lot of times what you'll see up here is they'll say something like 98 degrees. Be here, they'll define this one as x plus 40, and then you have to find the opposite angle. Okay? Let me give you a little bit more complicated problem just so that you can get an idea of how these might be used. Okay, so let's go ahead and do our little diagram. And we got to put arrows on here because this needs to be extended. Okay. And again, let's do a B, C, D, E. And I'm going to describe each of these particular angles not as, like a whole number, but something with variables in it, okay? So let's say that this one is y plus 20 degrees, all right? So let's do that and just put degrees out there. Let's say this one is 3x plus 5 degrees. Let's say this one is x plus 15 degrees. And let's say this one is 4y minus 15 degrees. And I want you to be able to solve for the x's and the y's. Okay, now that's a little bit trickier. You have to know what the relationships are. So, learning what we learned in this video and the last video that I showed you. Well, I know that 4y minus 15 is equal to 3x plus 5 because they're vertical angles, right? The problem is I've got two different variables, so how am I going to do that? That's not going to be helpful. I want to have one variable only. So I have to look for another relationship that also has a y. And here it is. Remember, these are called adjacent angles because they share a common side and a common ray. The other thing I know about them is that it forms a straight angle, and I know that this plus this would be equal to, remember they're supplementary, so 180 degrees. So this is what I'm going to do. 4y minus 15, which is this one, plus y plus 20 is equal to 180. Because again, it forms a straight line, so it's a supplementary angle. And now since I only have one variable, let's solve for the variable. So let's go ahead and do that. I really don't need these anymore because they're all additions and subtractions. So I'm going to say 4y plus y is 5y. Negative 15 plus 20 is a positive 5. It's equal to 180. Again, use these Roman numerals to divide your steps, please. Third step. Subtract 5 from both sides. 5y is equal to 175. Last step, divide by 5 on both sides. Y is equal to, 20 plus 15, so 35. Now I can plug those in, okay? And let's try that and see what happens. So now I'm going to get, let me just redraw this again. So I now know that this angle is 35 plus 20, or 55 degrees. I know that this angle is 4 times 35, which is what, 140, minus 15 is 135. I also know it's 135 because this angle, 125, sorry. Because 55 and 25 is equal, 125 is equal to 180. Now look what I can do now. Now I can solve for the x, because I know that 55, this angle and this angle are opposite angles, or 3x plus 5 is the opposite angle of 125, so I can do this. 55 is equal to x plus 15. Solve for x. Subtract, and you get 40 is equal to x. So now I got 40 here. This angle becomes 55, and I knew that because it's opposite of that one. And then 3x plus 5, third problem, is equal to 125. I'm going to get 3x equal to 120, or x is equal to 40. When I put 40 in there, I'm going to get 125. Okay, so you see how geometry works. If you find one thing, plug it in, and that'll be able you to find another thing. If you know your relationships, you're going to be in good shape. Okay, good luck to you.